Yeah, in addition to regular classrooms.
Beautiful. So everyone, I expect a few more people to be joining us over the next few minutes. We're getting ready to get started. If anyone would like to talk a little bit themselves about how their fall is starting, how things are going.
In addition to regular classrooms.
Feel free to do so. We are now live streaming on LPI's YouTube channel. I've also turned on the captioning. If it's on and it's bothering you, feel free to turn it off. You can do that under the More setting by hiding subtitles. And so if you change it to hide subtitles, if the captions are bothering you, feel free to do that. So, and if anyone else would like to be able to talk or share their camera during this, just let me know. Enter things in the chat or the Q&A. We'll be starting in one more minute. We're glad to have all of you with us here today as we talk about how we address controversial topics, in particular, those controversial scientific topics in which people may have non-scientific ideas about the science. So we'll be hitting those. During this seminar, this session, it's going to include a lot of discussion. So there'll be lots of opportunities to share things in chat. And you are also welcome to let us know that you would like to share your microphone. Just let us know if you would like to share your microphone so you can share your thoughts and ideas as well. And we will turn on your microphone and let you talk. We'll be starting in one more minute. You've got one more minute to grab your favorite snack, something to drink, as we continue to do this and have fun. So. And it's just about time now for us to begin. First of all, I wanted to introduce myself and my wonderful team here with me. So I'm Chris Jupla at the Lunar and Planetary Institute, and I lead our Sharing Planetary Science seminars. If this is your first one, we do hope that you'll join us again for another one. Sherelle, please introduce yourself.
Hello, everyone. My name is Sherelle Webb. I am the Public Engagement Lead here at the Lunar and Planetary Institute. So happy that you're joining us for our seminar on today.
Thank you, Sherelle. Grace, please introduce yourself as well.
Hi, everyone. My name is Grace Bodwin, and I'm an education specialist at the Lunar and Planetary Institute. And same as Sherelle, I look forward to getting to share with you guys and hear your input about this topic.
Yolanda, can you go ahead and introduce yourself briefly?
What? I wasn't ready.
You weren't ready. Sorry about that.
Wow. Hi, I'm Yolanda Ballard. I don't know who I'm talking to, but I'm Yolanda Ballard, and I am basically the program coordinator for the education department. I support LPI education and also the internship program as well for USRA. Glad to be here.
And Yolanda's going to be monitoring LPI's YouTube channel where people might be posting comments and questions during this. Sherelle is sharing the slides, and Sherelle and Grace are chiming in, and Andy is with us. I think Andy's mostly going to be quiet and in the background, but Andy, feel free to chime in and say something. Andy is our senior education specialist at LPI, and I think he's mostly going to be listening for this. So let's go ahead and let's start with a poll. So we just told you a tiny bit about who we are. Let's go ahead and find out a tiny bit about who you are. We're glad to have all of you with us. So we've got two poll questions here. The first one is a little bit about who you are and what you do. And the second one is whether or not you conduct programs for the public. So you are enabled to pick multiple selections for each of these. You can select multiple selections for each of these. We want to know a little bit more about who you are here for our Sharing Planetary Science seminar today. And while you're reading all of those choices, I'm going to give you 10 more seconds to finish answering, 10 more seconds to finish answering these choices for who you are. For those of you who are joining us on YouTube or by a browser that does not enable the chat and the polls, the choices include things like whether you conduct planetary science research or teach planetary science. Are you senior experienced planetary scientist? Are you a planetary engineer? Are you a student or an early career planetary scientist? Are you a scientist but not planetary? Are you an educator or an engagement specialist, or are you something else? And if you're something else, please feel free to enter what you are in the chat so we know a little bit more about you. And then the second question is, do you conduct programs for the public? The answers are yes, you give presentations. Yes, you help with or lead other public programs. Do you teach? You haven't yet, but you'd like to, or no. And you've got 3 more seconds to finish answering. 2, 1. And we've got a mixture of everybody here. A number of you, about half of you, do conduct planetary science research, and our Sharing Planetary Science seminars are predominantly for planetary scientists. So that's excellent. Some of you teach planetary science. Some of you are seniors or experienced. We have several of you who are early careers or students. We have a few who are scientists but not planetary, and we have a number of you who are educators or education specialists, and a few who are others. Again, if you'd like to enter more information in the chat about yourself, we'd be delighted to hear it. A lot of you give presentations or help with or lead other public programs or teach. There's a few of you who haven't yet but would like to, and a few of you who the answer currently is no. So we're glad to have all of you with us here today. And thank you. You've completed your Master's of Science degree and are looking for an advisor to work with for your PhD. That's awesome. Okay, Cheryl, let's go ahead and move on to the next slide. And Risk Communications Coordinator for NASA. Thank you so much. We're glad to have you with us, Doug. And yeah, I should have included other NASA type positions besides just scientists and engineers. Absolutely. So we're doing this as part of LPI's Sharing Planetary Science seminars. We've got several in the past that are recorded and are available online if you've missed some. Some of you have joined us for them before, and we're glad to have you with us again. Let's go ahead and do one more poll before we go forward. And this question is, have you ever witnessed someone arguing with a speaker during a public presentation? And we're gonna, this one's a shorter poll, so we're only gonna give you about 5 seconds to answer. Yes, about the science being presented. Yes, about a non-scientific idea. You're not sure, or no? We've got 4, 3, 2, 1, and thank you for everyone who voted. The majority of you, the answer is yes. You've heard people argue. Of course, that's what we do, we argue. Adrian, you're running okay, thank you for joining us. So let's go ahead and let's start our presentation. Sherelle, can we go ahead and go to the next slide, please? So there's a variety of controversial topics that come up during public engagement. Now, some of them are opinions, and we're not going to be talking here today about opinions. And we're also not talking about those topics where the scientific community is deeply divided, which happens quite a bit. Addressing those topics can also be problematic, and some of the same solutions that we're going to discuss today might apply. But today we're predominantly focused on controversial topics that come up about your science, where the person who is arguing doesn't really understand the science. And we're going to discuss some possible solutions for these. And many of us, as we just established in the poll, have dealt with this before. So next slide. A lot of this goes around misunderstandings about science. So when it comes to public programs, all of us who are dealing with science and science research and science education need to be prepared for the possibility that people don't always understand science, that sometimes Only a third of the Americans out there can really explain what it means to study something scientifically. And so when people don't understand what science is or how science is done, and they think we're just making it up, of course they think it's just opinions. And they may disagree with our opinions because they have opinions of their own. So we're going to be covering that a little bit. Let's go on to the next slide. And we're going to start covering this through an activity around the nature of science. So for each of these questions, I am going to post a poll, and I'd like you to think about how you think people might respond, how a member of the public might respond to this statement. So the statement right now, when it comes to controversial topics such as which foods cause cancer, there's no way for scientists to evaluate which scientific studies are the best. Everything's up in the air. How would a member of the public respond to this? Would a member of the public, somebody, your parent, a friend, somebody who comes to a program, somebody who comes to some of your presentations, would they say that this statement is true or false? I'm going to give you 5 seconds to answer. Would a member of the public say that the statement is true or false? 4, 3, 2, 1. And a lot of you say that a lot of people out there would say this is true or false. Many people out there would say this is true or false. But as scientists, what would you say about this statement? As scientists and science educators, what would you say about this statement? Please enter in the chat your reactions, how you would respond to this statement personally instead of a member of the public. And Sharon, false, this is false. Anyone want to add a little bit more to that? This is science is not easy. It can be done. So it's possible to evaluate it, but it's not always easy. More research is needed. So we need data. Thank you so much for all of this. So many people in the public say this is true, but many of you agree that this statement is false. It might not be easy, but it's false. More and there's some different thoughts in terms of the research itself and the quality. And so, but there's ways to evaluate the quality, right? Let's go ahead and let's do another one. Sherelle, let's move on to the next slide. And so here's a different statement. And what we're going to do is we're going to relaunch the same poll, but now with this question. So is science is a little like fashion. Something that's in one year can be out the next. Scientists regularly change their theories back and forth. Would a member of the public say this statement is true or false? We're going to give you a few seconds to answer here. 5, 4, 3, 2, and 1. And a lot of you say that the public would say that this is true. This is something that your parents, your friends, your neighbors might say is true. Does anyone want to comment on this one? Is personally, in person, what do you think about this statement? Is it true or false? And if so or not, why? A mixed bag. It's a mixed bag. Anyone want to share any more about it? Do scientists just regularly change their theories back and forth like fashion? Theories have to be well tested. Good point, Sharon. Thank you.
I also think sometimes people can be resistant to the changing nature of science. And they'll say, well, I learned it one way and therefore it shouldn't change.
That's true. Sometimes people don't understand that science can change. Science is not a whim. Thank you so much, Paul. Yep, absolutely. It's not an easy yes or no answer, though. But sometimes, yes, William, when you're just looking at the headlines, it seems like this is possible. So it can be very confusing, right? And we do rely a lot on social media, and they don't really understand what science is and how it works sometimes. Science does change. Pluto's no longer being defined as a planet. So let's go ahead and do the next slide. Thank you all so much. Let's do another one. And for this one, I'm going to relaunch the same poll. And the question is, so often a scientific principle or theory just doesn't make sense. In those cases, you have to accept it and move on because not everything in science is supposed to make sense. Would the public say this is true or false? Would a member of the public say this is true or false in your opinion? I'm going to give you 5 more seconds to answer. 4, 3, 2, and 1. So we've got a mixed bag here. Several of you say the public would say this is true, and some of you say that the public would say this is false, right? Makes sense varies with the audience. So what somebody thinks makes sense and somebody else, if someone doesn't really understand the science and feels like they just have to learn it and say it even though they don't understand it, that's one thing, absolutely. But should scientific principles and theories make sense? Should you as scientists just accept things and move on? What do you think about this statement? There were 2 parts to the question. So the first one says, often a scientific principle or theory just doesn't make sense. And then the second part, sometimes you have to accept it and move on. If it doesn't make sense, you need to study it closer. That's great. And Paul, it has to make sense. The problem is sometimes you're not in that same field and things haven't been explained well. You haven't don't understand it yet. So, so there's lots of different possibilities here. Let's go on to the next one. The more that you think you know, the less you actually know. All theories become laws this way. And actually, we've got a different understanding about theories and laws that depending on which sources you look at. And we can talk about that later. Here's another one. Scientists may have trouble predicting and explaining the behavior of thunderstorms because some things just don't behave according to a consistent set of rules. You could substitute thunderstorms with something else if you'd like. You can substitute predicting and explaining the behavior of volcanoes, or predicting and explaining the behavior of galaxy rotation, whatever you'd like here. The point is, would a member of the public say that some things just don't behave according to a consistent set of rules? I'm going to give you 3 more seconds to answer here. 2 and 1. And the majority of you do say that some members of the public at least would say this is true. What would you, as scientists and science educators, say about this statement? Is it true? Is it false? Do some things just not behave according to a consistent set of rules? The rules are consistent, but our understanding might be incomplete and changing. Or we might not understand those rules. Great point, Daniel. There's a lot of things about nature and chaos theory that we're still learning. Does that mean that it doesn't have rules? We don't understand all the rules. We might understand some of them. Our understanding is incomplete. So let's do one more, I think. I think we've got one more here. Next slide. In stuff like personal relationships or poetry, things can be ambiguous, but in science, the facts speak for themselves and science is never ambiguous. Is that true? Is science never ambiguous? Does it always speak for itself? What would the public say? Would the public say that's true? Would the public say that's false? These questions came from a series of questions developed in an attempt to understand how students understand science. Let's go ahead and end the poll here and share the results. Here we're a little bit more of a mixed bag. Some say true, some say the public would say it's true, some say the public would say it's false. What do you say? Is science never ambiguous? Or is it sometimes ambiguous? And Sean, do you say variability is part of nature and not easily modeled? So that's a good point, a good point. It's not easily modeled. It's hard for us to understand everything. Can you think of a case where science appeared somewhat ambiguous? Does anyone have an example of a time when science might be ambiguous? If it's not fully developed, if we don't fully understand it. So radiation effects on biology, we might be getting different results, right? Wayne, thank you. The Hubble constant or the nature of dark matter, quantum mechanics. Awesome. So there's some things that are a little ambiguous, absolutely. And answers are not always true or false, right? That's a good point. Wave particle duality. Okay, thank you all so much. Shira, thank you for participating. So this was sort of an introductory activity to talk about science. It is a process. Thank you so much, Sharon. There's so much that we're understanding about it and so much that we need to think about when we are talking about science to the public in terms of their misunderstandings. Cheryl, can we go on to the next slide, please? Oh, let's skip this one. Let's just keep going. So part of this, there's some misconceptions out there about science that make it difficult to address a topic. So here, as an example, if you are talking about a planet like Mars or the moon, a planetary body, and the subject comes up about the age of that planet or how it formed, there might be people who might disagree with your presentation around the age of an object in the solar system. What are some misconceptions about science that might make it difficult to address those people who have concerns? And how can we help clarify what science is and isn't? Science is always evolving, that's true. So the point about topics might be controversial because they haven't reached that evolutionary point. Here we're not talking so much about something where the science is still poorly misunderstood. Here we're talking about you're presenting something where the science is very well understood by the experts. That doesn't mean it can't still change. What are some misconceptions about science? So misconceptions might be this idea that science can still change. Sometimes definitions change. So this idea that science is completely unchanging and never changes, that's a misconception that's out there, that science never changes. And a great point, Elizabeth. Awesome. Thank you, Milan. This idea that anything can be proved with science, that science can absolutely prove something forever and ever. And once that's another misconception. Absolutely. Thank you, Daniel. So those are a couple of the misconceptions about science. So how can we help clarify what science is and isn't? The idea that science can only evaluate the present. Great idea. Does anyone have any ideas how we can help people understand what science is? We're going to give you just a couple of seconds to think about that, maybe post something, and then we'll move on with some ideas and ways to deal with this. Thank you, Rick. Science permits questions for which there may not currently be an answer. There are too many answers that cannot be questioned. That's an interesting point. Yeah, we have answers that not so much that they can't be questioned. I would disagree with that, Rick. I think everything can be questioned, but that we do have a preponderance of evidence. Maybe.
Another misconception can be that the public can interpret arguments among different scientific schools of thought as viewing the science as totally unsettled. So, if people are arguing about the age of the Earth to the, third decimal place, the public can view that sometimes as, oh, I guess we don't know the age of the Earth. So I think sometimes we don't communicate our science well in saying, no, here's what we really know versus here are the parts that we're still working on.
Absolutely. Sometimes we seem to overemphasize where we're still working on it and leave out here's what we know based on the data. Yeah, great points, everyone. We might want to start with the definition of science itself. We might want to point out where something is scientific versus a religious belief, and that's not within the realm of science to decide. Science itself doesn't change, the process doesn't change, but our knowledge does. Absolutely great points here. The idea that there's no such objective reality and objectively true data. We have to also take the data and we have to interpret it, right? That's a great point, Adrian, that we have to take the data and then interpret it, and two different people might look at the same data and it might lead them to two different interpretations. But sometimes the preponderance of people looking at that data might agree with one interpretation, then we gather more data to still finish answering it. So great point. Great points, everyone. Thank you. Let's go on to the next slide. So here's a few other pieces of information for us all to think about and to use moving forward. So there's a site, University of California, Berkeley, called Understanding Science 101. And this site has a lot of great information about what science is and what science isn't. And one of the starting points is that science asks questions about the natural world. We study the natural world. Science does not study supernatural forces and explanations. When you are studying things that are outside of nature, it's no longer science. It still exists. There's different philosophies and religious beliefs that might understand things outside of the natural world, the natural universe, things that can be studied using scientific data and scientific methods. So that's something that comes down to the definition of science. So starting off, as I think it was Elizabeth said, it would be good to look at the definition of science. This is something about the definition of science and what it does. Next slide. And there are these misconceptions that make it hard for people to understand what we're talking about. And one of those misconceptions was the idea that science is unchanging and absolute. And it's true that many ideas are very well established. They have lines of evidence. They're unlikely to be overturned. But even really well established ideas are subject to modification as we get new evidence and new perspectives. And those scientific ideas at the cutting edge of research, they may change, right? Especially as we're testing out different explanations and gathering new data. One more piece of background information, the next slide, about another misconception here that's out there. And I see some good conversations in the chat. Thank you so much. So next slide, please, Sherelle. One other misconception that you've already mentioned, folks, thank you so much, is that because scientific ideas are tentative and subject to change, they can't be trusted. This is a misconception. It can seem as though we're changing our minds. It's a normal way to do science, though. All scientific ideas are subject to change. Many ideas are supported by multiple lines of evidence that are extremely reliable and unlikely to change. So ideas about the age of our solar system have been supported by multiple data points, multiple lines of evidence, and that scientific idea is unlikely to change. So let's go ahead on to the next slide. Okay, so here's another opportunity for us to discuss how we might respond to something. Here's an example of a scenario, and we'll do some other scenarios in a bit. Let's say you just gave a presentation about Mars, but during that presentation, during the question and answer, somebody asked a question and that provoked a passionate discussion about the Big Bang. And so people had strong beliefs and strong thoughts about the Big Bang and whether it happened or not. What do we do? Sherelle, can you go ahead and push forward? I've got a few questions for us to talk about here. So how should you, as the presenter, address this issue coming up during your presentation? And after talking about the presentation, we'll move forward to talk more about other events. But if you're giving a public presentation, you're in a lecture hall or wherever you are, you're doing a webinar, how would you address this during it? Some people, let's say a member of your audience strongly disagrees because they believe that the Earth and the solar system and the universe was formed 6,000 years ago. How do you address this? How do you deal with this? What are your thoughts? Everyone, please feel free to chime in the chat.
I'm thinking that the best way to address this type of issue during a presentation is to give them either a short answer or ask to speak with after presentation is over if your response is going to be lengthy. And that's way it would not disrupt the flow of the presentation or kind of throw you off of your game with your thoughts.
Great point. Great point. And yeah, I see Paul said something very similar. This is not the point of this presentation. We could talk afterwards. This is not the time for that discussion. Thank you. So maybe later we'll have more information, more data from the James Webb to help clear and address some of the different ideas that are out there. Defer the question to the end of the presentation, and maybe it does become something that we do privately instead of having everybody in the audience who was there to listen to your Mars presentation have to sit through a lengthy conversation on this topic. Great points. Ask that questions be held until the end, in part to stave off this. That's a great point, Adrian. That way questions, and you ask them to think about it, and or another presentation, absolutely, that maybe this might be something we deal with another time. Okay, so instead of that, what if it wasn't during a presentation? What if this comes up during a public event? So you are either in a class or you are sitting at a table, or you are having a conversation, let's say with the Girl Scouts. So the audience is younger potentially, and it's more one-on-one. You didn't just finish a presentation that was a formal presentation. It's more informal. How do you deal with it then? So you could say that we're here to talk about Mars, and I'd prefer that you talk about the Big Bang with somebody who's a specialist in cosmology. That's one way to do it. Acknowledge that it's a fascinating area. They might invite somebody else to talk about it. You might want to repeat back the question. It's a great point, Elizabeth, that you've heard them, that you've heard the question. And then you might want to defer it potentially based on the exact question. These are great ideas. Because you do want to hear them. You want to make sure that they know that you have heard them. Let's do the third case here. So let's say it comes up in a conversation. You are having a conversation with one or two or three people, and you were talking about Mars. Someone asked you a question about your science, and you're talking about Mars, and somebody wants to know more about when Mars formed, and they want to disagree with you about when Mars formed. They think it happened 6,000 years ago. What do you do then? So using props, that's a great idea. We were talking about Mars. We were talking about the Big Bang. Here's a giant inflatable Mars or a Mars globe, and let's come back to Mars. But sometimes conversation does just flow like that. You can go ahead and go with it and share your understanding, maybe. Sometimes, let's see, good point, Doug. Scientists are competitive. They seek to disprove ideas, and research results are critiqued. So the research out there about when Mars formed and how it formed, we have lots of different data. And so you might enjoy discussing it more with the person about what the data is, and about that it's not just one person's idea, but that this data has been supported, and other people, as Doug said, are looking to disprove things and haven't been able to disprove that data, haven't been able to disprove it. And so you could just talk about it more one-on-one. Absolutely. Great points, everyone. Sherelle, can we move ahead a little bit here? We talked a little bit about things that you could do. Are there things that you should avoid doing during these different scenarios? Are there things that you should not do during any of these scenarios that you don't want to do? Don't get into a fight. Don't be dismissive or pompous. Great points. Yep. Getting into a fight probably isn't going to, whether it's physical or verbal. Don't belittle someone and don't laugh at them and their ideas. Great points. Don't answer beyond what you know. Don't, start making up answers. It's important to say that scientists may have had a different idea before, but as more data came in, it changed. Great points. And you don't want to dismiss other people's ideas outright. Absolutely. Sherelle, did you have something you wanted to say?
Yeah, I wanted to add in, and I guess being transparent, and if you don't know anything about it, I mean, stating that you don't know much about that particular topic, or that's something that they brought up. It just reminds me of an incident that happened, but just being transparent to say, I don't know much about that topic, and leave it at that, being honest.
We talked about misconceptions about science. There's also misconceptions about scientists. And one of the misconceptions about scientists is that everybody knows everything. So absolutely, absolutely. Great points. Let's go ahead and let's go to the next one. And you don't want to give the impression that you don't know anything about it. If somebody wants to argue with you about the age of Mars and you know some things about it, you can share a little bit about what you do know about it. Absolutely. So here's some recommendations from the National Center for Science Education on dealing with denial. And so here's some that could apply. One is to be prepared. Maybe if you think that there's certain disagreements that are going to come up when you're doing a public program about whatever it is, you might want to understand a little bit more about the claims or concerns of those disagreements. And you might be ready to cite the consensus of the scientific community, understanding what the consensus is, but do be respectful of the concerns, but don't engage in fruitless debate. Don't sit there and argue if you're not going to convince them and they're not going to convince you. And yeah, don't misrepresent the scientific consensus by saying that it's not, that it's controversial. If it isn't controversial. If it is controversial, acknowledge that. That's important. Don't present two sides as though they were equally scientifically credible if they're not equally scientifically credible. So that's a couple of recommendations. Let's go on to a little bit more feedback here. Yeah, I'm sorry, next slide. Solutions. So we did one scenario there with Mars. Let's do a couple more scenarios here. And the first one, let's say there's a science festival at a school and you've been invited to come and participate in it. As a planetary scientist or somebody who works with educating people on the planetary science, you're there, you're at a table, you're having a conversation, and an adult comes over and says that since we're still studying how planets formed, scientists don't really know any more than the Bible. How do you respond to that? How do you deal with that? Everyone feel free to say science has come a long way in the last 2,000 years when the Bible was written. So we've learned a lot more. It's a good point. It's a great statement.
This is what makes it fun. We don't have all the answers yet.
We don't have all the answers yet. We're still learning. That is one of the fun parts about science. Absolutely. Absolutely. Any other thoughts anyone has?
I think in a situation like this, it's important to remember what you're there for. And if you're there primarily to engage the students at the school, then maybe focus on that and have a discussion with this adult at a time that isn't going to be taking away from the kids.
Maybe talking a little bit about radioactivity and dating techniques. That's a great point. That's a great point. Thank you, Grace. I appreciate that as well. And Dave. And if anyone else wants to speak up, yeah, anyway, every religion has origin theories, and within the scientific community, there's always evidence to support those theories. And so understanding that this might not be the place for a long conversation with any one person, but acknowledging that there's a difference between faith-based beliefs and science and what science does, and just sort of reminding people that science seeks to study the natural world and the natural universe, like how the planets formed, and things, questions as to whether or not God created them is outside of science. That's not what scientists study.
A cardinal who defended Galileo said that the Bible shows you how to go to heaven, science shows you how the heavens go. That's my answer.
That's a cool quote. So a lot of good ideas here. Thank you all. Advances since the Bible. There's a lot of things that we've learned about but yes, good points, Elizabeth. We don't want to exhibit body language that is dismissive. Be polite. I wouldn't try to disprove everything in the Bible, because you don't want the conversation to be about the Bible. You want it to be about the science and the planets. Absolutely. Great points. Let's go on to the next scenario. So you're having a conversation in a crowded elevator, and a 12-year-old asks you about the moon landings and says that her father, who's standing next to her, says that the moon landings were fake. How do you respond to that? Ideas are all welcome. Why do you think that? That's a great question. Why do you think that? Why do you think that? And there's entire websites with lots of information about the thoughts of people who have said that they're fake, that you can read up on if you're interested in that. Does your father think that we built this giant rocket for no reason? That's a good question. We just have to make sure that we're not being dismissive to the father or the child here. Oh, that's a good point. The Russians wouldn't have permitted an American hoax to cancel their programs. Ask if the father was involved in faking it. Was that what you told him or her? Was that what you told them? So maybe you change the conversation from being a conversation with the child to being a conversation with the adult. So that way the child isn't put in the middle, which is a very uncomfortable place. You don't want to place this child, this 12-year-old, in the uncomfortable place where they are having to support their parent. And yeah, so it would have been very difficult to fake the moon landings. So that's a great. Just saying, it's nice that you respect your father's opinion, maybe. Sherelle, I see you making a face. Does anyone have any other thoughts about that?
I just think that it's a difficult question to approach, because either one, it's either way, it's just a sticky situation, right? It's a sticky situation because if you then give an honest answer, then the father would seem like he lied to his child. And then you don't want to in turn lie to the kid. So it's just a sticky situation.
Exactly. And as Elizabeth said, you're in a crowded elevator. So ask the child what they think. That's a good point, Andy. Thank you. So yeah. So you can state some arguments for why it wasn't fake with the whole elevator or the child, and share the LRO website with the hardware that we left on the moon and show them, so there's a number of arguments as for why it wasn't fake. Or you can have a conversation directly with the parent, the father. You can have, you can say, I have lots of ideas. I have lots of information about why they weren't fake, but I'd prefer that we wait until we get off the elevator. If you have time, a few minutes to talk in a minute, I'd be happy to share some of those bits with you. Artemis, talk about our plans to go back to the moon. You can't go back to the moon if you haven't been there. So, and how hard it is to keep a conspiracy a secret. Yes. And the tests the retroreflectors that we left on the moon, that telescopes with lasers that continue to reflect off of. So we've got so many pieces of information to support that the moon landings weren't fake. The thing here we have to be careful of is we don't want to sound pompous or dismissive, and we do want to sound respectful, and we're in a crowded elevator. So all of those things. Great ideas, everyone. Let's go into the last scenario here. So halfway through your public lecture on the Mars climate and how it's changed, how it's evolved, and you're giving this lecture for about 100 people, and you're halfway through, someone loudly states out loud that you've just proven that climate change on Earth is natural and not human caused. How do you deal with that? Please hold all the questions until the end of the presentation. Anything else? That's always a good follow-up, and we've already talked about some of the things you can do at that point. Does anyone have any additional ideas or other ideas? Security? Right, security. We're talking about two different planets and different processes, and the research that I'm presenting on isn't related to what's going on here on Earth. Correlation does not equal causation. You might have to, Kristen, that's a great point. That might take a little bit of time to explain different time frames. Absolutely. Why do you think that? That is risky, Doug, but it could be. Yes, I like both of. I like that very much. I can tell you that climate continually changes. Awesome, awesome, Jim. It's not that it's changing, but that the rate it's changing is faster than the natural cycles we know about. So you can try to give a short explanation in the middle of your talk, or you can defer it to the end, or both a little bit, you know, a really short explanation and deferring the remaining conversation to the end and to a private conversation. And so these are all good points in terms of short explanations. You don't want to go on to a really long explanation, and you don't want an explanation that might be difficult for your average adult to follow. So thank you. Sherelle, let's go on ahead to the next slide. So earlier I gave you some do's and don'ts, but here I wanted to share with you that there are a number of websites that have resources on dealing with people who are rejecting your science, rejecting your scientific argument. And again, here, we're not talking about cases where the science is very much still in dispute. We're talking about cases where you are presenting something, you are sharing something, and you're dealing with someone who doesn't understand science, doesn't understand how science is done, doesn't understand with the scientific process, and either thinks that all science, once it's proven, is done, that it can be proven, and that the fact that they learned back when they were in third grade should still be true, and that what you're saying is now wrong, or the reversal, that all science is completely up in the air and we're just making it all up. So we've got 3 websites here, and there's a page, a document that has these websites, as well as additional information on our Sharing Planetary, on Sharing Planetary Science website as well. So yes, let's go ahead and let's, that's a great point. Grace, can you go ahead and add, thank you so much. Grace is adding all the links here for you to also link to immediately if you'd like. While we're doing this, I have a few more poll questions for you. One of them here, let's pretend like I asked this before we just spent the last 45 minutes talking about it. Let's pretend like I asked this about 45 minutes ago. How prepared are you to respond to a question or an argument about, let's say, the age of the solar system? Going to give you a few seconds here. Five, 4, 3, 2, and 1. And we have a variety of answers here in terms of how prepared you felt about an hour before. So that's good. And let's go ahead and do, let's we did that, we did that. And let's do this one in terms of your experience. Has anyone ever asked you a question about science that was very difficult to respond to without insulting them? Five, four, three, two, one. And some of you, many of you, most of you have. Some of you haven't, but most of you have. So anyway, does anyone have any final questions for the group on this topic? Any things that you want to bring up? Dave?
Yeah, I was going to, this story comes from Dave Hathaway. He used to be in charge of solar physics at Marshall Space Flight Center, giving a talk and at international conference. At some point, this guy gets up and challenges Dave to admit that the theory that the sun is predominantly hydrogen and helium is bogus, and it's made out of iron because the solar spectrum is rich in iron lines and so on and so forth. And Dave so he listened very politely and then told the guy that's crackpot science and explained why he was wrong. Dave said that what kept him out of court was that he called the science crackpot. He didn't call the man crackpot. So that's an important but narrow difference. Next thing Dave knows is he's got a letter that filters from this guy to his congressman over to NASA congressional liaison down through the center to him saying, you have no business telling my constituent that his science is crackpot, et cetera, et cetera, et cetera. And Dave writes back and says, that's exactly my job. That's how science works, is challenge and question.
It comes back to how science works and this misunderstanding about how science works. I thank you. I think that it's what you just said in terms of the story. It is important not to listen to and not use dismissive terms. So, but to acknowledge that there's a difference between what science is and how science works, and these ideas that don't always use the full data, that ignore the data. Rick, good point. Never pretend to know everything. Try to follow up things appropriately. And that's another. So we said you could have the questions wait until later. You can give the person websites with more information about it. Get an email from them and send them. You may or may not want this person to have your email address, but if there's a way for them to have the website with more information about it so that they can do the research themselves and start to understand, in this case, that the spectrum of a sun or a star doesn't tell you, you have to take it as a percentage. It's not just what lines are showing up there, right? There's so much more than that. There's a lot about light and spectroscopy that's misunderstood by the public. A huge amount that's misunderstood, starting with what light is and how it works, and especially about spectroscopy. And some of that is inadequately presented even in textbooks and things. Make sure that we don't make science personal. It's not about us. It's not about them questioning us. They may think it is, but it isn't. It shouldn't be. Absolutely. Thank you, Kenda. Good points. It's about the science, not the scientist. So all of those are great points and great stories. Does anyone else have anything final, questions or ideas that they haven't had a chance to express here yet? And I think that's our 5-second wait. Sherelle, can you move along to the next slide, which I think is the last slide? We did not talk about flat earthers. We did, thank you, Jim. There are just so many potential topics. And so what works and what doesn't work for dealing with the age of the solar system and dealing with climate science should also be true to some extent about flat earthers, although they might, I think they're presenting themselves as being, I haven't yet really come to grasp with looking at the arguments that they are presenting. I need to see what scientific arguments the flat earthers are presenting in order to understand that, in order to be able to have good explanations as to why it isn't true. Does anyone have any thoughts that they would like to share in terms of what some of the beliefs, the fundamental beliefs of flat earthers are, and some of your favorite responses to dealing with flat earth arguments that might come up when you're giving a presentation, because that definitely happens. Feel free to enter in the chat, or if you would like to talk verbally, I'd be happy. It's about belief that might be, when it comes down to belief as opposed to scientific arguments, if what they have is pure belief and not based on science, then you might not be able to change their minds. If it's some sort of internal philosophical belief or something else. And again, good point, Jim. I think that the more that we can do to help people understand what science is and how science works, the better they can assess and understand the arguments, and that we build these things on data, that we test it, that we're competitive, as was said earlier, and that different people are trying to disprove things. So absolutely, great points, Jim. Going to give everybody about 5 more seconds to finish filling out our evaluation poll. We appreciate your information, and you are welcome to give us feedback. There's also a survey that's going to pop up with just 2 questions that you can use to fill in any other feedback you might have. And we always appreciate that. And I should add that this evaluation poll is purely anonymous. I cannot tell who answered which. So don't worry if you have anything that you want to say in it. That anyway. Yeah, Adrian, good point. There's a lot of easy ways to disprove flat Earth. I don't know that there's easy ways to convince somebody who's firmly a flat earther. That might be a different issue, depending on where they're coming from and whether it's something that was taught to them by someone that they deeply esteem and admire. And thank you, everybody, for joining us. I really appreciate it. I'm going to give you 5, 4, 3, 2, 1 more seconds to finish filling out the survey. And again, when you leave, there'll be another survey that you can use to fill out things. Some information about this, including a handout that we gave before on this topic, is available at our scientist engagement website. We've got a full schedule, including some other ones that are coming up. Flat earthers have very little depth. Interesting. So, and yeah, we need to listen to them. And sometimes someone might be trying to make a very valid point or a valid argument to us. So Judy, good point. We need to listen to them, because there might be something in what they're trying to express that is a good point, and when they're arguing with us. So, and sometimes for people who joined us who didn't see the poll, I apologize. Our polls came up for people who have one app, and if you're joining the Zoom through a different format, you might not be able to see the poll. So thank you all so much for your time and for everything that you shared. I appreciate you. Sherelle and Grace and Yolanda, thank you for your help. And we hope to see you again for our next seminar in about a month, okay? Have a good evening.
Yay.
Yay.
Okay, goodbye.
Thank you all.
There was a total of about 11 on average. There, it got up to about 15 for a few minutes, but then dropped off. So
Okay, awesome.